Okay, so we'll do a little video here on impulse momentum theorem. Got my pen ready to go. Okay, so the IMT, impulse momentum theorem, let's fix this, is not really all that difficult. The major idea is that, we do our force diagram like normal. The surface will always have a mu k. You'll have weight, you'll have normal. You'll be pulling it, and there'll be some friction. So this will be FMG, this will be FN, this would be FP, you could call it FSP, or FT, whatever force is making it happen, and then this is the friction. So we go through and we find everything, and then once we're done finding everything, we then incorporate the time. So when we incorporate the time, we then would find the impulses for everything. Impulse push, impulse weight, impulse normal, and the impulse created by the friction. What you see real quick is that just like the forces, the impulses also cancel out. And so what we're left with is a battle between the impulse created by the push and the impulse created by the friction. So to find impulse, we just take the force times the time. And what the impulse momentum theorem says is that if you have the net impulse, well, that equals a change in momentum. If you have a change in momentum, that's the mass times the final velocity minus the mass times the initial velocity. So really, you just take the impulse created by the push and subtract the impulse created by the friction. That gives you a net impulse. Now as long as it starts at rest, V0 is 0, you can get rid of all that stuff. And it's as simple as setting that equal then to mv and then solving for v final. And then you can check this with your summation, Newton's second law, and then follow that up with a magic physics formula, number 1, and you should get the same answer. And it's really pretty much that simple, Shouldn't take a whole lot of time. It takes a little bit of time, but what doesn't? So hopefully this will help you if you're struggling with it. Let me know if you still have problems.